Hello, this is a video introduction to the pebble game. So what is the pebble game? Well, it allows us to to construct an algorithm where if we're given a graph G, we can tell where G sits in the rigidity matroid. And here we're just going to be considering the 2-3 rigidity matroid. So for example, we might want to ask, is G2-3 sparse? Is it 2-3 tight? Is it 2-3 spanning? Is it a 2-3 circuit? So the pebble game will let you, variations on the pebble game will let you answer any of these questions. So here are the key things to know about the pebble game, and then we'll look at an example together. So the pebbles represent degrees of freedom. So if we're thinking about placing a graph in the plane, we have 2 degrees of freedom for every vertex, right? Because we have an x coordinate and a y coordinate, and we're free to choose where the x coordinates and y coordinates, okay? Now, of course, whenever we have an edge between 2 vertices, that's really like a bar in the framework, and that's going to restrict 1 degree of freedom between those 2 vertices. So putting an edge in a graph takes away a degree of freedom, or we expect that's what's going to happen. So we're going to put 2 pebbles on each vertex to start, and we're going to take pebbles away from vertices when we insert edges. And we're going to, when we insert, we're going to look for 4 pebbles on the endpoints of our 2 vertices to insert an edge. If we find 4 pebbles, 2 and 2, then we'll insert the edge, direct the edge away from one of the vertices, and steal the pebble from the vertex that we're taking the vertex that we're directing the edge out of. If we don't have 4 pebbles on the endpoints of the edge we're trying to insert, then we're going to be able to follow arrows away from those vertices to search for pebbles. So let's see what I mean by that. So let me see here. I want to do a new share and share with you this pebble game. Okay, so here's a triangle, and this is our original graph G. We know, because we've been doing rigidity theory together all semester, that this is a 2-3 sparse graph. Let me just check that the settings are correct. Okay, so how do we play the pebble game? Well, the first thing we do is we initialize our game board. So we're going to put 3 vertices down, no edges between them. And to initialize the game board, we put 2 pebbles on each of the vertices to represent our degrees of freedom. And now I'm going to first try to insert an edge. I guess I'm going to try to insert the edge BC. That's in my original graph on the left. When I insert it on the game board on the right, I did have 2 pebbles on B and 2 pebbles on C, so I met that condition that I had 4 pebbles total. And I stole the pebble from C, and I directed the edge out of C. So let's see what happens now. I think the pebble game in this computer simulation is going to try to insert the edge between A and C. Notice there are only 3 pebbles here, so we're not going to be able to insert it right away, but this vertex C, I can follow the arrow to a vertex that has 3 pebbles, and what I'm going to do is I'm going to steal one of the pebbles from B, and to show that I've stolen it, I'm going to reverse the arrow. So let's see what happens. And that's exactly what happens, okay? So I stole the pebble from B, put it onto C, and then used that pebble when I inserted the edge A, the edge AC, okay? So what's going to happen in this next iteration? The only edge left to insert is the edge from B to A. I don't have enough pebbles because I only have 3, not 4. I can't search. I can't do a pebble search from vertex A because I can't get out. I only have inward directing edges. I don't have outward directed edges. But from B, I have an outward directed edge, and I can search. I can search for pebble that's on C, and I'm going to bring that back. And what you see in the end is I stole that 1 pebble from C, so C has nothing left. and I reversed the edge when I brought the pebble back. And now I have 3 pebbles left, and those 3 pebbles represent the 3 degrees of freedom that we can never get rid of by adding more bars, right? They're my 2 translational degrees of freedom and my 1 rotational degree of freedom. Let's try the pebble game with a more complicated example. So for here, let's think about this. This is not a 2-3 tight graph. It has the right number of edges to be 2-3 tight, but I'm wasting an edge down here. I should really probably move maybe one of these diagonals or something from down here up here to rigidify the top too, because right now the top is floppy and the bottom is sort of over constrained. Okay, so let's play the pebble game here. Again, this is the graph G I want to understand, and I need to initialize my game board by putting all the vertices down and 2 pebbles on each vertex. First, I'll try to put in the edge FC. There were 2 and 2 pebbles, so that's fine. I insert the edge directed away from F, so I steal one of F's pebbles. Now, I want to insert the edge from E to C, and if we go back a move, we can see that E and C still have 2 pebbles each, so it's fine to insert that edge. I don't have to do anything, do any pebble searching, and I stole the pebble from E, so it's directed away from E. Okay. Now, I'm trying to insert the edge EF, and let's go back a move to see what happened. If I try to insert the edge EF, I don't have enough pebbles. I have 1 here and 1 here. So I'm going to need to search from F and bring back one of these pebbles, reversing the edge. I'm also going to need to search from E and bring back the other pebble. And so you can see in the next move, that's exactly what happened. The outward edge from F got reversed when I took a pebble from C, and the outward edge from E got reversed when I took a pebble from the other pebble from C. And then I had 2 and 2. I inserted the edge EF, directed it away from E, and stole a pebble from E. Okay, so now I can keep going. It looks like I wanted to insert the edge ED next. Let's see what we had to do that. So ED has only 3 pebbles, but I have 1 out edge from E, and I can move along it to F, steal a pebble, and reverse the edge. So I stole the pebble, reversed the edge, and then I directed the new edge from E to D. So we can continue. Now I have this C to D edge, and you can think about what happened before. So I had no pebbles here on C, but I could search to find those 2 pebbles. So we do that. Those edges now point into C. I direct my edge away from C, so I take one of those pebbles away. All right, let's keep going. That was fine. I had 2 pebbles and 2 pebbles, so I just directed away from B, taking a pebble away. Ooh, something probably happened here. So to insert the edge AF, I'll have to search for 2 pebbles. How am I going to find them? I think what I'm going to do is a depth first search. I don't know if we'll search for C first or, oh yeah. So probably I'll go this way, and maybe I'll do this one first. And then maybe I think I'll do this one. So this edge should get reversed, and these 2 edges should get reversed. And that's what happened. Now those 2 got reversed, and that one got reversed. And I inserted one more step. Let's see what we had to do there. I'm going to need to pebble search twice, here and here, and pebble search once from here. That's in. And now I have 4 remaining degrees of freedom, but can I insert this last edge here? Well, if I wanted to insert the edge from F to D, I'd need to do some pebble searching. I can bring pebbles back to D, but after I bring that pebble back to D, and I guess I can bring 1 pebble back to F, and maybe 2 pebbles back to F, and 1 pebble back to D, but I don't think I'll be able to do anything after that. So the idea here is that I could bring this pebble back to, the pebble from A back to F, reversing the edge. And I could bring the pebble from C back to F, reversing the edge. And then I'd have I'd have 2 pebbles on F and no out edges. But if I wanted to bring 2 pebbles to D, remember I just brought this pebble back to F, I could search here and bring one of these 2 pebbles back to D, but that would involve me reversing both of these edges. And I don't want to steal, I could go out here this way, but I don't want to steal any edges from F because I need edges on F too. So those are kind of frozen now, okay? Anyway, that is enough for this.